You know, hydraulic systems are kind of like the invisible muscles of our modern world. I mean, they move, they shape, they lift with a force that is just unimaginable. But here's the thing, all that incredible power has a surprising weakness, a silent killer that works from the inside. Seriously, just think about that for a second. How can one person with just a little lever command enough force to flatten a sheet of solid steel like it's a piece of Play-Doh? It seems like actual magic, right? But nope, it's pure physics. And understanding that magic is the key to seeing its biggest vulnerability. So in this explainer, we're going to pull back the curtain on that very magic. We'll look at where all this power gets used, we'll expose its number one enemy, see the kind of damage it can do, and then, and this is the important part, we'll reveal the simple secret to keeping these massive systems running strong. And we're going to wrap up with a single number that will totally change how you look at every big machine you see from now on. All right, let's start with the secret sauce itself. How is all this insane force generated so easily? Well, it all comes down to one simple, elegant law of physics. It's all thanks to a guy named Pascal. Basically, his law says that if you put pressure on a fluid in a closed container, like hydraulic oil, that pressure is felt equally everywhere at the same time. And here's the trick. The oil is incompressible. You just can't squeeze it. So if you apply a little bit of force on a small area, you create a ton of pressure. And when that same pressure pushes on a much bigger area on the other side, boom, you get a massive output force. A tiny push in equals a gigantic push out. That's the whole game right there. So, now that we know the secret, let's see how this brilliant idea literally powers the world all around us. And trust me, you see these systems in action every single day, probably without even noticing. Think about the world of high-tech manufacturing. Precision is everything. Hydraulics give those CNC machines the incredibly strong yet super controllable force they need to cut and shape metal parts with microscopic accuracy. Hey, remember that 10,000-ton press we talked about? Well, this is where it lives. In car factories, giant hydraulic presses use that incredible force multiplication to stamp and form car doors and hoods out of flat sheets of steel. It's just amazing. Okay, this one's easy. The next time you pass a construction site, look for those big, shiny silver pistons on the excavator's arm. That is a hydraulic system, right out in the open. It's what gives that machine both its smooth, fluid motion and the raw muscle to dig through rock. And all of this brings up a crucial point. These systems have to be ridiculously reliable. I'm talking about the brakes on a high-speed train, the steering on a giant cargo ship, or, get this, the flight controls on the airplane you're flying in. We are literally trusting our lives to the power and precision of hydraulics every single day. Okay, so we've established these systems are powerful, they're precise, and they are everywhere. But they have an Achilles heel. A problem that starts so small you can't even see it, but it quietly destroys them from the inside out. So here's the kicker. Even though it's a closed system, it's not perfectly sealed. As those big pistons move back and forth, the level of oil in the main tank goes up and down. That means the tank has to breathe air in and out. And when it breathes in, it sucks in whatever is floating in the air around it. Dust, dirt, tiny metal particles, you name it. And that's when the system's lifeblood gets transformed into its worst enemy. That clean, smooth fluid that's supposed to lubricate parts and transmit power, it turns into a liquid sandpaper. It becomes this gritty, abrasive sludge that just grinds away at the most delicate, most expensive parts of the system. So let's zoom in a bit, CSI style, and see exactly what happens when this abrasive sludge starts pumping through the veins of the machine. The damage it leaves behind is, well, it's systematic and it's catastrophic. So someone actually went and asked maintenance pros, hey, where does it hurt the most? And the results are so telling. The pump, which is the heart of the system, and the control valves, the brain, they take the biggest hit. Why? Because they have the tightest, most precise clearances, so they are the first to get torn apart by that contaminated fluid. Let's follow the destructive path of just one tiny particle. We're talking 10 microns, way smaller than a human red blood cell. So first, it gets breathed into the tank. Then it's sucked into the pump where it scratches and gouges the filing machine surfaces. From there, it gets blasted at near supersonic speed through a relief valve, basically sandblasting the delicate parts and causing pressure to leak. Then it might get jammed in a control valve, causing the machine to stick. Finally, it scrapes along the main cylinder wall, creating a tiny leak that slowly bleeds away the machine's power. One invisible particle leaves a massive trail of destruction. And all that internal chaos, it starts showing up on the outside as real-world problems. The machine gets sluggish, or maybe its movements become jerky and erratic. It starts running super hot. Key parts like pumps and valves start failing over and over again. You'll hear weird noises and see leaks popping up as the seals get chewed up. These aren't just random, unlucky breakdowns. They are all symptoms of one single root cause. Now, I know this all sounds pretty bleak, right? But here's the really good news. This is an almost completely preventable problem. The solution isn't some crazy complex technology. It's just about a shift in mindset. It really boils down to this. You have to stop thinking about fixing things when they break and start focusing on stopping them from ever breaking in the first place. That's what we call contamination control. Because when you protect the fluid, you're protecting the entire multi-million-dollar machine that it runs. And the practical steps are actually pretty straightforward. Use good, high-quality breathers on the tank. They're like N95 masks for your machine. Don't ignore them. When you check the oil, take a sample from the fluid that's actually circulating, not from the sludge at the bottom of the tank. And hey, when a filter gets clogged, that's a good thing. It means it did its job. Change it. Don't just let the dirty oil find a way around it. And that brings us to the single most important point of this entire explainer. If you remember just one thing from our time here, please make it this number. 70 to 80%. Just let that sink in for a moment. What in the world could that possibly represent in the world of hydraulics? That's right. The overwhelming majority of all hydraulic system failures, all the expensive downtime, the crazy repair bills, the lost production, it's not because of bad luck or random mechanical problems. It is directly caused by dirty oil. And that means most failures are not just predictable, they are, in fact, preventable. So, the next time you see a massive crane effortlessly lifting a steel beam, or you watch an excavator digging with incredible force, you'll know the secret. The biggest threat to that powerful, expensive machine isn't some massive overload or simple wear and tear. It's the thing you can't even see, the unseen enemy, a single, tiny particle of dust.